Alrighty, good morning or good afternoon, ladies and gentlemen. Happy Friday or whenever you catch me. Today we're going to go over our last remote lesson. You'll notice here I'm going into 3.4. Last section we went into 3.1 and 3.2, so I'm skipping 3.3 because it has a few tricky aspects, and I actually have a foldable that I'd like to put in with it. So I want to work through that with class. Keep in mind, I am going to be checking your understanding of 3.1, 3.2, 3.3, and 3.4. So we are going to be covering some of this in class. However, I want you to understand that the bulk of the teaching is going to be happening online. So I'm not going to take another 3 classes or 2 classes to teach these again. So please make sure you're watching the videos. At most, I'm going to be checking our understanding through a number of interactive ways just to see if you're getting the concepts rather than just sitting down and reteaching the entire lesson again. So keep that in mind. There's not going to be any homework for this section, but again, there is going to be stuff that pops up on our quizzes and our tests that are related to these. So please do watch this video. So we're going to jump right in. Previously, we were talking about what a rational number was, how to define it, how to figure out which one's bigger, and essentially just working with fractions in general. There is also the idea of working with decimals, but for now, we're going to think of it just generally as multiplying and dividing rational numbers. Now, we definitely know about multiplying and dividing rational numbers, like 5 times 6 is an example of a multiplying and dividing rational numbers. However, we're going to think about a more general case. So with that, I'm going to do a bit of recall first. So what we're going to go into first is the idea of if I have an eighth, and I'm adding an eighth, and I'm adding an eighth, and I'm adding an eighth. So this example right here. The way I can think about it visually is that I have 1/8 here, I have 1/8 here, 1/8 here, and 1/8 here. Well, that's a bad fraction. And I imagine, like, say this is pizza, this is different people eating one single slice. So in total, how many slices are taken care of? Well, I can just add them up. I can make this 4/8. And some of you will already see from the visual aspect that this 4/8 can also simplify to a half. And for those of you who are a little bit less visually inclined and more mathematically inclined, maybe you see that there is a common factor of 4 that I can pull out to get there, but it should show up both ways. Now, we've learned previously, say I had 2 plus 2 plus 2 plus 2 is equal to 8, but rather than write out a bunch of additions, I could also write this as 2 times 4 is equal to 8. So any sort of repeated addition becomes a multiplication. So in our minds, we're going to start thinking about this rather than 1/8 plus 1/8 plus 1/8 plus 1/8 as 4 times an eighth. And that's equal to 4/8. So keep this in the back of our mind. We're going to build a special case for why this is, but I'm going to look at a more general case first. So keep in mind, this is going to be important later, but we're going to come back to it. For now, we're going to look at just multiplying fractions. So if I am multiplying a fraction, like say I have 4/7 times 3/8. One of the things that's nice about this is, oh, sorry, this is way too thick. You don't need a common denominator. So unlike with addition and subtraction, I don't have to treat it this way. The reason being is I'm going to subdivide each of my sections into sevenths and eighths together. I have a visual model that I'm going to show you when we get back, but for now, the way I can think about this is step 1 is going to be multiply the numerator or the numerators or the top together. So first step, I'm going to have 4 times 3, and then I'm not going to solve it just yet. Step 2 is going to be multiply the denominators together, or I'll put the bottom So in this case, I would do 7 times 8. Whoops, not 78, 7 times 8. So this is going to give me 12 over 7 times 8. This is going to give me 56. So notice how when I multiply, I make it over one fraction, but I multiply both the tops and the bottoms together. I'm not cross multiplying, I'm just kind of grouping them with top and bottom and then multiplying them together. And then step 3, you can already see I can simplify this. So I see 12, I see 56. When I see this, I can look for the largest number. Like here I found a common factor of 4, but if you don't see a common factor, you can always divide by the one that you do know. So for example, with 4/8, I can maybe I see the 2 first, so I have 2 over 4, and then I go, oh, both of these are divisible by 2, so I take another 2 and I get 1 over 2. So in this case, I don't immediately see what number I can simplify by, so I'm going to divide this by 2, and I'm going to divide this by 2. So this is going to give me 6 over, this would be 28, and then, oh, both of these are still even. I could have kept going, so I'm going to divide by another 2, so I'm going to get 3 over 14. And then from here, I have an odd number. 14 isn't divisible by 3, so I'm stuck. So for those of you who maybe noticed, 12 and 56 are both divisible by 4, so I could have done it in one step to get right here. 12 divided by 4 is 3, and 56 divided by 4 is 14. Now, I'm going to show you a shortcut with our second example here. So say I have 11 over 7 times 21 over 8. And this shortcut will apply to the previous one too. Normally, if I had an addition, so say I had 4 over 8 plus 3 over 2, I could find a common denominator, or I could realize that this could simplify down and I could make it, again, 1 over 2 plus 3 over 2 to give me 4 over 2, which is 2. Now, with multiplication, we have an additional way. So previously, when you were adding and subtracting, you could only reduce within one fraction. However, it doesn't matter what order we multiply in, so now I can check up and down. I can check also along the diagonals. So notice how our multiplying sign looks sort of like an X. I'm going to follow that X across both ways and see if those numbers can also reduce. So 11 and 8 are no good. 7 and 21 are though. They're both a common factor of 7. So I'll say this in class, and you'll hear this from me a number of times. Good mathematicians are lazy. I don't want to multiply 11 times 21 if I don't have to. If I can make those numbers smaller without changing my answer, I'm absolutely going to do that. So I see 21 goes into 7. I see 7 goes into 7. So I'm going to reduce this to 1, and I'm going to reduce this to 3. So my new fraction is going to be 11 over 1 times 3 over 8. And now I have a much simpler multiplication. Because before, I could have easily, if I didn't see it, have done that. But that's a messy number, and I can reduce it after the fact. So then this becomes 33 over 8. So again, to show how I'm getting that, I'm doing 11 times 3 on the top and 1 times 8 on the bottom to give me 33 over 8. And this is already simplified. So the shortcut, there's going to be a caution. So when multiplying, So when multiplying, you can simplify first before going into your steps. And the way we can do this, if I have A over B times C over D, check A, sorry, I'm going to use a different color, or the ones that you can check A and B, C and D, but then you can also check B and C and A and B, or A and D, sorry. So notice how that makes a big multiplication. However, I said there's a caution attached, so caution appears later. The reason being is it doesn't so much apply here, but there is something that we have to be careful of that I'll talk about in a bit. And it relates to how when we go across like this. So for now, just keep that in the back of your mind. Right, you can write that down as a rule, but I'm going to go into a special case. So this is actually our special case from the top with different numbers. So if you're multiplying a whole number, remember, whole numbers can be written as fractions. And the key thing is, if you have something like 4, the fraction is going to be 4 over 1. Not 4 over 4, 4 over 1. Because when I divide something by 1, it doesn't change. If I did 4 divided by 4, it's going to be equal to 1. So 4 would equal 4 over 1, 7 would equal 7 over 1, negative 37 would equal negative 37 over 1. So when I have a question like this, what it's really asking me to solve is 4 over 1 times 7 over 9. The reason why this is important, oftentimes I see the mistake of where you multiply both the top and the bottom. We don't want to do that. That would be like multiplying 4 over 4. So this is going to give me 4 times 7 over 1 times 9. So this is going to give me 28 over 9. Take a look if I can reduce it. I can't, so this is my final stop. So keep in mind, I'm not multiplying the bottom, I'm just multiplying the top. Alternatively, I can treat it like I am multiplying 4 over 1 times 7 over 9, and I don't run into problems. Okay, so far I've been talking about improper fractions. So for example, 3 over 2 is an improper fraction, but I haven't talked about mixed fractions. So if you remember, mixed fractions was where we had a whole number that showed the total amount that we had greater than. So this, for example, would be 7 times 5, so it's 35, so it would be 36, because I'm adding this 1, over 7. And this would be 24 from the 6, and then add 3, so it would be 27 over 4. So what happens if I have a multiplication of 2 mixed fractions? So I have a fancy way of solving these, and I call it Mr. Sproul's method for multiplying mixed fractions. So we're going to work through this example here. So step number 1, don't do it. Multiplying mixed fractions is guaranteed to run you into problems because of how they are set up. I'll go into why in a bit, but what you actually want to do is convert any mixed fraction into an improper fraction. So for example, I don't want to try and solve this. I want to try and solve 36 over 7 times 27 over 4. Now, these aren't great numbers to deal with, but I can reduce. So now I have a multiplication here. I see that this, I can take out a 4 to make this 1. I can make this a 9. So how I got that was I divide this by 4 and I divided this by 4. 7 doesn't go into anything. I'm stuck here, so I have 9 times 27 over 7 times 1. So we're going to have calculators available to us. So 27 times 9 is 243 over 7. So this is going to give me 34. So 34 times 7. And this is going to be 5 over 7 as my remainder. Now, this is already as simple as it goes, so I don't have to worry about that because I simplified first. If I was to look at this, my brain automatically thinks, hey, multiply the whole numbers together and then multiply these together. So I would get something like 30 and 3 over 28. So in my mind, that's what my first step would be. The issue with this is, first off, it's different than my answer, but really it comes down to what 5 and 1 out of 7 and 6 3/4 represent. Really, what these are saying is 5 plus 1 over 7, and 6 3/4 is 6 plus 3 over 4. And then I'm multiplying these together. We're going to learn about how to multiply this together, but what this actually, to solve this properly, I would have to multiply the 5 to the 6, I would have to multiply the 5 to the 3/4, and then I would have to multiply the 7th to the 6th and the 7th to the 3/4. So to solve this as a mixed fraction, I would end up with 5 times 6 plus 5 times 3 over 4 plus 1 over 7 times 6 plus 1 over 7 times 3 over 4. Now this will give me, after a long period of time, I will get 34 and 5 over 7. However, it's going to take me a long time to get there. I have 4 multiplication steps. That's 4 more chances for me to make a mistake. And if I miss any one of them, I'm going to get a wrong answer. So when you see a mixed fraction and you're multiplying them, don't bother trying, just turn them into an improper fraction. If you have a calculator, you could also turn them into a decimal, but turning something into an improper fraction makes it much easier to multiply. A rule of thumb that I always like to use is that mixed fractions, they're good for adding and subtracting. Oops, sorry. And seeing the approximate value. So what I mean by that is if I had 28 over 4, that's kind of hard to see what I'm talking about. I'll do 29 over 4. As opposed to 7 1/4, way easier to tell what that is. Off the top of your head, you're like, oh, I know it's 7.25. Whereas 29 over 4, you have to think about it for a second. All right. So Mr. Sproul's method for multiplying mixed fractions, don't bother, convert them to an improper fraction and work from there. If the question asks you for an answer as an improper or a mixed fraction, it's always going to be easier to then convert it back. But why? So I actually went into this. I apologize up here. So all of this is our but why. All right, next up, multiplying fractions and decimals. So what happens if I have 1.4 times 4 over 9? Steps. Convert all decimals to fractions. The reason being is that fractions are easier to multiply because you're always multiplying a whole number together, whereas with a decimal, you have to remember some rules about multiplying decimals, and if you don't have access to a calculator, it's a pain in the butt. So to convert, I have a very simple rule for myself. So I have 1.4. I want to move the decimal place over once. So 1 move. So this is going to become 14. The denominator is going to be a 1 with the same number of zeros as space is moved. So in this case, 1, 0. So it's going to be over 10. So my new fraction is going to be 14 over 10. The reason I have 10 is that I moved the decimal place over here one time, so I add 1 0. If, for example, I had 2.73, I'd want to move the decimal place over twice to give me 273, and then I'm going to put it over 100. If I had 0.01, I'm going to move the decimal place over twice again, so I'm going to have 1. And again, I care about how many moves I've done, so I'm going to do over 100. So don't worry about these numbers, just think about how many times you've moved the decimal place. So with that in mind, I can rewrite this as 14 over 10 times 4 over 9. And from here, I notice, hey, I have some things to cancel out. I can either cancel out the 10 with the 4 or the 14 and the 10. So I'm going to stick within the fraction because that's always safer. So I'm going to make this 7 over 5 times 4 over 9. And I can't do anything here, but I end up with 7 times 4 is equal to 28, and 5 times 9 is equal to 45. And then from here, I have my answer. So again, if you have a calculator, multiplying by decimals isn't so bad. However, if I have something like this, it's much harder to write. I could convert the fraction to a decimal, but converting fractions to decimals without a calculator is hard. And you also run into a problem with something like, say I had 1.4 times a third, and I wanted to go decimal. So I would have 1.4 times 0.333 repeating. When do I stop? When does it not matter anymore? As opposed to if I instead did, well, 7 over 5 times 1 over 3, I end up with 7 over 15. And then I'm good. I have my answer. It's already reduced. It's already simplified. So when multiplying fractions and decimals, fractions are again easier to multiply than decimals. All right. Last little chunk. We're getting close to the 30-minute mark or the 25-minute mark, so I'm going to try to wrap this up. Dividing fractions. So I have a quarter divided by 2 over 7. So my rule, maybe you remember, flip the second fraction change the divide to a times and solve. So 1 over 4 divided by 2 over 7 becomes 1 over 4 times 7 over 2. So all I did here was I flipped these two digits with one another. Notice how I didn't change the first one, I just changed the second fraction. And then from here, I would have 7 over 8, and I'm done. Now, first up, I'm going to look at why this rule works. Now, one of the things I've been talking about is that eventually we want to get away from using this division symbol. The division symbol is helpful when we're in elementary, but when we have really complex equations, or even just like a couple extra steps, it suddenly becomes much harder to talk about and understand what is being divided. So to avoid confusion, higher levels of math just make a bunch of fractions. So what 1/4 divided by 2/7 is actually saying is I have 1/4 as my numerator, and then I have 2/7 as my denominator. Now, one of the interesting things about this is, notice how this is all on the top, so it's just 1/4. This 2 is now under one division line. It's under this line here. This one is under 2 division lines. So it's sort of like saying divide by 7. So this is a double divide, and this is similar to a double negative. How a double negative becomes positive, this becomes times 7. So what that ends up doing is flipping this up to the top, but this one is still under one division line. So this sort of looks uncleaned up, like that. All I've done is brought the 7 up, but I notice I still have my fraction, except it's upside down, and if I fix it a little bit, if I just rearrange how it looks, I now have the 1/4 times 7/2. Now I know a lot of you have already done this rule, but if you're wondering why it was the case that it is, this is sort of what's happening and why we flip it. And it also shows why we flip the second one, because this 1 isn't under any division lines. This 4 is under one division line, so it's going to pop under this one. Now, when we look under this line here, we ignore this one. We just look at this line and this line. We don't have a triple division in this case. Even though it kind of looks like it, we're ignoring that because of how it looks over here. So just keep that in mind. And what that line's applying to, it just applies to the 4. But again, if you're wondering why we do this rule and why it works, this is why. All right, question. This is where we get to our caution. Do I simplify and then flip, or flip then simplify? Or does it even matter? So the question is, hey, I saw up here, I have 1/4 divided by 2/7. Why don't I change it to 1/2 divided by 1/7? Can I do that? The answer is no, I can't. So it does matter. And notice I've drawn a caution line that's gone all the way around it through some of our work from way up here with our rule. So again, the point that I was trying to make is that this forms a times. I want to avoid doing it with division. So remember, 3/4 divided by 2/5, if I'm going to work through this example, really is asking me 3/4 times 5/2. Notice how when I flip, I can't simplify. I get 15/8, which is 1 7/8. If it doesn't matter, I should get the same thing if I cancel out. So I can cancel these out here. So I get 1, I get 2, so I end up with 3/2 times 5/1, and this gives me 15/2, which is equal to 7.5. So this here, this second step, doesn't work. So our rule here is only simplify diagonally with multiplication questions. For division questions, change into a multiplication question. Before simplifying. This is another common mistake, and because we flip it, it does change the value of our answer, and we want to avoid that. So my rule of thumb is if you see a division between two fractions, don't even think about canceling. Just flip it first and then think about how to do it. Lastly, if I have something like this where it's a big mess, this will be our last example. I have an improper fraction with a mixed fraction. I'm going to go 7 over 2 divided by, and I'm going to convert this to an improper fraction. So I have 7 times 3 plus 4. The way I kind of convert these is I multiply this way, and then I add the value here. So I have 7 times 3 is 21, plus 4 is 25 over 7. I don't want to cancel out. This is a trap. So 7 over 2 times 7 over 25. So then from here, I can multiply 7 times 7 over 2 times 25, and I get 49 out of 50. So keep that in mind. Hopefully this was helpful. We're going to revisit these on Monday, as well as learn some new skills. For Monday, or for the weekend, please make sure if you haven't already, to pay your school fees. That way I can get you your workbooks, because we're going to jump right into new stuff. And then as well, make sure you're bringing your interactive notebook, because we're going to be going into or adding foldables into that as well. That's all I have for you today. Take care, stay safe, have a good one. Bye.